Saturated solutions and solubility. Here are these pictures again. Again, we're trying to help you see it conceptually so that you better understand what the terminology is that we use. When we say dynamic equilibrium, what we're saying is there is a solid lattice that came to us in chapter 12, and there's a back and forth between ions becoming hydrated with water and those ions going back into the solid. That's what we mean about dynamic. And again, the picture one more time. So hopefully between the two pictures, you have an idea of what's happening in a solution. So the way I decided to approach this, having taught this many times, is by saying, what's an ionic solid? Something like sodium chloride, calcium chloride, where we have the ions. So then I say, let's take one specific solid, sodium chloride. We know that it will dissolve in water to form ions. Now you'll say, oh, I really don't know that. No, you do. If you've ever cooked pasta, you maybe put a little bit of salt in the water and it does dissolve, okay? So if we're going in the forward direction, the term we use is dissolve. If we're going in the opposite direction, the term we use is crystallize. Or maybe you remember from 1210, you made a precipitate of a lead salt, okay? So we've got our terms here again, solute and solvent. Sodium chloride is the solute, water is the solvent, and then we have these ions in solution. Yes, those things you had to learn back in chapter 2, all right? So when I use the word solubility, people tend to refer it to how much solid do I need to form what is called a saturated solution. So that's a new term. You know what a solution is, but what is saturated? Well, if it is saturated, it is making that equilibrium. Ions are coming and going. There's undissolved solute, there's ions in solution. But if I have what's called an unsaturated solution, there is less solute than I need to form a saturated solution. This section is very small, but very important. We will be talking about precipitation in chapter 17. We're talking about solution formation in chapter 13. So I kept stuck with my sodium chloride. You have to choose a temperature, and then you look at this graph. Now, don't laugh too hard, but this is the same picture I had in high school. And you see I'm a little bit older than you. So what you have on your x-axis is temperature. And what you have on your y-axis is grams of salt per 100 grams of water. And you get some kind of line. That's really what you get. If you are above the line, you can see here it says saturated. If you are on the line, you are also saturated. But this is where you've got that equilibrium happening. If you are below the line, you are definitely unsaturated. So we'll talk about this graph in a later section of the chapter, but for now, just focus on sodium chloride. There it is. Its solubility does not vary much with temperature. But if I choose 25 degrees centigrade. Again, a lot of graph reading in this class, and they said that's what they're doing with you guys in high school, but I really haven't noticed it, okay? And I look at it, you can see that it intersects the y-axis at, you can't really see it here, but it's 35.7 grams of NaCl for every 100 grams of water. If I have 12.5 grams, that's less than the amount, I will say this solution is unsaturated. It's less than 35.7. If I have greater than 35.7 grams, I will say that it is saturated. Again, not too difficult to follow. What might you be expected to do? You can try it in your homework. I'll probably do it in class. But I want to close this section with something called a supersaturated solution. Now, I use the title rare bird. I don't know if that was a good thing, but students think there's going to be a lot of solids that do this. There aren't. Sodium acetate is really the only one that does this, the only ionic solid. And it forms what's called a supersaturated solution. Here's where I am sad we were not in class. And as I describe this to you, I'll tell you why, okay? Under certain conditions, and again, sodium acetate, you can have a greater amount of solute than is needed to form a saturated solution. So you're looking at this solution and it's very clear. So you go, well, it could be unsaturated, but this is again the rare bird. This is actually a saturated solution. And what you do is you drop in a little seed crystal. You put a little crystal of sodium acetate there, and all of a sudden, solid starts to come out of solution. It crystallizes in a shot and it'll arrive at saturation. Well, in our class demo, I usually have an Erlenmeyer solution system, and I have my sodium acetate supersaturated sitting here. I think it actually goes up to the top. And essentially, once I drop in a seed crystal, it totally turns into a solid. Remember, it once was full of liquid. So what I like to do between those 2 points is put this over a student's head upside down so that they can see that it has gone totally from an aqueous solution to a solid. I also let students touch it, and this is very hot. It is an exothermic dissolution process. So if I were to draw the solid and the aqueous, it would be sitting in that direction. Please do not read more into this. Every semester students do. This is a rare bird. This is a rare example. It makes a great lecture demo. In the old days, many of the chemists were men. I mean, I'm talking 1900s, early 1900s, and they often had beards. When they were working in the lab, what would happen is there would be stuff that fell out of their beard, and that would actually be a seed crystal to make something start to precipitate out of solution. When you take organic, you will have some labs where you actually do those things. It doesn't mean you should grow a beard. It just means that you will actually have a seed crystal or scratch the side of the container in order to have a nucleation site for precipitation to occur. Remember, I told you there's a lot more to this chapter than meets the eye. I don't mean to add things, but I say it just so that you see there is a reason to study these things if you're going on in some sort of STEM or medical field. It really is part of your foundation.